NMIT had recently completed a pretty conventional steel and concrete structure, and the opportunity arose where they could use some additional central government funding and try something different.
We set out to create an arts and media building that was light, was airy, had plenty of space, and gave us the opportunity to use that space as flexibly as possible.
There's a wonderful light in the building because of the glass, and a warmth because of the wood, and the whole ambience is uplifting.
The LVL that's used in this building is produced in Nelson, but it's also produced north of Auckland. So one of the reasons behind this demonstration project was to show that we could use this high value product such as LVL in the New Zealand market.
Timber has some obvious pragmatic advantages. It's lightweight, it goes together easily on site, it's visibly a sustainable product. For us as architects, there are some intangible benefits too, and those are in the way it looks and feels and the effect that has on building users. The outcome here speaks volumes of those intangibles, the fact that people love coming to this building, and it has a real point of difference.
The attraction for timber actually came partway through the development of the project, in as much as we knew we wanted to use something that was sustainable, but it wasn't until we actually were given the opportunity to look at laminated veneer lumber that we saw how not only effective it was as a building material, but also how aesthetically pleasing it was as well.
What was important for this building is we had to show that it was buildable, not by the large contractors, but also by the regional contractors that we have here in Nelson. What you can see as you walk through this building is the very simple beam to column joints, the beam to floor joints. What this meant is when we went to build the building, it went up very quickly and there was a large saving in construction time.
We're incorporating the first use of damage avoidance design in a timber structure in New Zealand, and we've proven that process is realisable in a small industry in Nelson at a time when that technology is very important for New Zealand moving forward.
We were already in this building when the earthquake occurred in Christchurch, but we were very conscious that we were in a state-of-the-art building that had the ability to deal with earthquakes.
The building makes use of pairs of rocking timber walls that have been post-tensioned. As the building moves in an earthquake, these walls will rock and they will dissipate the energy through steel energy dissipators. What that means is the building, as well as being safe and will ensure everybody gets out of the building alive, it also means it will be able to be occupied immediately after a major event.
Our experience using LVL and in the engineering of this building, we would love to use those processes again as part of any new build, and certainly in the context of our experience of this building, we wouldn't hesitate to do so.
I think the real benefit for us as practitioners is it's given us a model for a timber building that we're now converting into more commercial uses, and we're seeing that that's becoming more viable as our experience grows and as the industry's experience grows.
It's a real success for the Nelson region and for the New Zealand timber industry because it showcases that we can actually do multi-storey timber construction.